Hi, this is the second in the series of IBM Code Patterns that show you how to build secure enterprise-grade hybrid mobile applications using IBM Mobile Foundation. My name is Shivakumar and I'm a solution architect at IBM India Software Labs. The increasing focus on digital transformation has led to more and more use cases where organizations want their enterprise apps to be usable even when the device is offline and later synchronize the data with the enterprise when the device comes online again. In addition, organizations want to leverage the benefits of hybrid mobile applications where a single code base developed using standard web technologies works across platforms Android, iOS, and Windows phones, thereby enabling organizations to more easily embrace the policy of bring your own device. In this code pattern, we will show you how to securely implement the mobile offline synchronization use case by using IBM Mobile Foundation's JSON Store collections. JSON Store provides encrypted on-device storage and automated data synchronization for better app performance and offline access. JSON Store enables persistent storage of JSON documents that are encrypted using AES 256 encryption. In case of more than one user on a single device, you can segment protection by user with password protection. JSON Store provides data indexing for efficient searching and it provides a mechanism for tracking local only changes to the stored data. JSON Store is similar to technologies such as local storage, indexed DB, Cordova Storage API, and Cordova File API. However, features such as data encryption, multi-user support, and keeping track of local changes are unique to JSON Store. In this code pattern, we will show you how to leverage JSON Store for secure offline login, secure downstream and upstream synchronization of data from Cloudant NoSQL database, and secure storage of the synchronized data on the device. In this code pattern, we will extend the demo app MyWord from the earlier code pattern to be fully functional even when the device is offline. As a quick recap, the MyWord app allows citizens to report civic problems in their municipal ward. After first time login, when the device is online, the civic problems reported in the user's municipal ward are stored securely on the device using JSON Store, which is initialized using user's username and password. At a later time, when user launches the app and the device is offline, the login credentials are used to reinitialize the JSON Store collection, which succeeds only if the password is correct. Post successful login, user would still be able to browse through the civic problems as data is now available offline from the JSON Store collection. The next time the device goes online, the data stored on JSON Store is automatically synchronized with Cloudant database and user would be able to see updated data. Post a successful online login, the JSON Store collection's password is updated with the current password so as to take care of password changes. This code pattern also demonstrates upstream synchronization with Cloudant database. Users can report new civic problems even when the device is offline. The new data is stored securely on the JSON Store and is automatically uploaded to Cloudant when the device comes online. Images from cloud object storage are cached locally for offline usage by using the imagecache.js library, which is based on Cordova File API. Similarly, image captured from camera in report new civic problem page is stored on the local file storage and is automatically uploaded to cloud object storage when the device comes online. If you have a more stringent compliance requirement of having to encrypt the images stored locally on the phone, then following is the recommendation. Encode the image as base 64 string, encrypt it, and write the output to disk. Store the file path and other metadata such as key, salt, and initialization vector inside the JSON store collection. When it is time to decrypt the data, look up the metadata from JSON store collection, read the encrypted data from the disk, and decrypt it using the metadata. Let us see the demo app in action. When there is network connectivity, user will install the app from App Store and launch it. Mobile app sends the user entered credentials on the login screen to mobile first server, where the mobile first security adapter is invoked to validate the user credentials. If authentication succeeds, mobile app initializes JSON store collection with the user provided username and password. JSON store collection synchronizes data with the Cloudant NoSQL database via the mobile first sync adapter. Parallelly, mobile app fetches the authorization token from cloud object storage via mobile first adapter and initializes the image caching plugin with the cloud object storage's authentication token and endpoint URL. Mobile app reads data from the synchronized JSON store collection and shows the list of civic problems on the home screen. User can click on a problem report to see its details. Image caching plugin loads image from cloud object storage and caches it on the local file storage for offline usage. User can report a new civic problem by clicking on the plus button. They can grab the device's geolocation, take photo using their mobile camera, enter a problem description, and click submit. Upon submitting the problem report, a new entry is made into JSON store collection, which automatically synchronizes it with the Cloudant database. Other users who log in afresh or click the refresh button on their mobile app can see the newly reported problem and its details. Let us now see the app's functionality when the device is offline. User launches the app and enters his or her credentials on the login screen. Given that the device is offline, mobile app leverages JSON store to validate the user credentials as follows. Mobile app tries to initialize the JSON store collection with the user provided username and password. JSON store init succeeds only if the correct password is entered. Recollect that the JSON store's password was last set when the device was online and user authentication had succeeded after making a call to the security adapter. If authentication succeeds, mobile app reads the data from the JSON store and shows the list of civic problems on the home screen. User would be able to see the details of problems that he or she had seen previously when they were online. They can report a new civic problem even if the device is offline. They can grab the device's geolocation as before. take photo using their mobile camera, enter a problem description, and click submit. When they click the submit button, the new data is stored securely on the JSON store and image is stored locally on the file storage. Back on the home page, the newly reported problem and its details can be seen. Since the device is offline and data is not yet synced, other users won't be able to see this new problem. When the user's device goes online again, the new data is automatically synced with Cloudant via mobile first sync adapter. At this point, other users who launch the app afresh or those who click refresh button would be able to see the new problem reported. Let us also see a scenario where data is updated on the Cloudant database. I am updating the problem description of this report. Back in the mobile app, after the user clicks the refresh button, they would be able to see the updated data. Step-by-step code instructions to make your mobile app work in offline mode using JSON store are documented in detailed.md file. This document walks you through the code changes needed to support offline login, downstream and upstream synchronization of data from Cloudant, and storing it securely on the device using JSON store collections. Hope this series of IBM code patterns help you in faster development of your enterprise mobile apps. And thank you again for your interest in IBM technologies.